All right, I'm back. So this is for part two. I'm gonna do a quick introduction um, to a couple things before we get started with the actual experiment that are in the lab manual. So just make sure you have the manual open so you can read certain things as I go through this with you. So starting on page 50. So we've got the two equations there. And as I mentioned, that x is the cross product, and it just multiplies two vectors together to give you another vector. And it makes it only depends on the sizes of the vectors and the angle between them. So when they're 90 degrees, it's at a maximum of sine 90 degrees equals 1. So that's basically just moving that cross product into the more angular representation is just what equation number 2 is. Just go ahead and read all the theory behind it as you go through. I've already talked about the right-hand rule. And let's go on to question 7. And question 7, again, just break down equation number 2 so that you can see the 4 different factors that have an effect on the force of the magnetism that we're looking at here. Now, for question 8, you're going to have to draw a graph, and it doesn't have to be exact, but just realize that it's effectively a graph of equation 2 from page 50, where you're drawing a graph of f as a function of I, and you're going to just make sure to label your axes and then state the slope, and just use, again, equation number 2 to figure out what the slope is going to be as when you make that graph. So don't feel like it has to be too exact. You're just trying to get a graph of again, current versus force. So what don't overthink it. Just consider how the one's going to change with the other one. Now, for question number 9, this is one where you will need the right-hand rule. And just so you know, current is a positive flow of charge. So when current's moving in one direction, you can use the right-hand rule and move point in the regular direction. It's a positive charge. So positive current, positive charge. So just make sure to use the right-hand rule in question 9. And what's most important is figuring out if the force is going to be pointing up, the force is going to be pointing down, sideways, if there's going to be no force. Just depending on which direction the force is pointing, what effect it'll have on what weight your scale is reading. So that's just a little hint on question 9. Now, wanted to go through our equipment before we get started on the experiment here. Now, in the lab manual, you'll see the picture of an analog scale where we have, you've seen these before in chemistry or at a doctor's office, where we've got the sliding individual masses that you'll move from one side to the other to try to balance. Now, doing that in this experiment would probably take forever. So we're just going to use a digital scale for our purposes, and that's going to allow us to take quicker measurements, quicker readings. And it's, there's really no downside in this case to using that. Now, do note that on the bottom of page 52, there is a quick description that doesn't make a lot of sense when you first read it, especially because, I'll just explain it to you now. It says the current loop SF42, that's this guy here. It's basically how we're just connecting what current we're going to run through. And so this is current loop SF42. It says it's got a length of 4 inches. That's incorrect. It's got a length of 4 centimeters. So do cross out the 4 inches and replace it with 4 centimeters in your lab manual, so that you've got the correct value there, because otherwise you're in rough shape, because it'll give you wrong values, and it just also mess with your units significantly. So that's your current loop. Now, how we're going to be setting this up, we've got this permanent magnet with a, I guess this is the North Pole and the South Pole. We also have basically these current leads that are going to be supplying current from our voltage power generator. The way we're going to run it in a current generation mode, because what matters to us is the current. So how we're going to set this up, we're going to start off by finding the mass of our permanent magnet, and it's going to be in your lab manuals, in the data tables provided to you, but that's going to be 163.8 grams according to our digital scale here. And I can just show you, 0.9 there, and then currently that's in kilograms, but we'll be working in grams in the lab, in the data table. So be aware of that. Now, what we'll do is we turn on our power supply, and we set all the knobs to 0. Now, depending on how you want to run your power supply, you've either got to, you're either trying to change the voltage or trying to change the current. In this case, we're trying to change the current. So what we want to do, the way these power supplies work, is we want to set the current value to 0, and then we can just add voltage as much as we want, because what's the limiting factor in this experiment is the amount of current. So this is what's really sort of controlling the overall amount of either voltage or current. Both of these are just limiters. And you see this red light here, that's basically indicating that we're in current adjust mode. So if I increase the current past the voltage threshold, we'll then be in voltage adjust mode. Anyways, what that means is now we can just individually adjust the current passing through here. So I'll slowly move this and try to get it to 0.5. And as we do that, we're going to see a difference in our measured weight on the scale. And just to show you guys, that's ending up looking here like 163.3 grams. So that's changed from when we had no current whatsoever in the experiment. Now, what we're going to be doing as in the lab, we'll just adjust this to various values, to 1 amp, to 1.5 amps, 2.00 amps, and all of the measurements we've made have been painstakingly made to make sure that they're correct to 3 significant figures here. So it's 2.00 when it's actually there. So you'll have that data available to you, and from there you'll be able to find the mass difference, or really it's the weight difference that that the scale is feeling, and from there it calculates. You can calculate a force that there's a hint above the data table in the lab manual to show you how to calculate that force, and from there you'll have you'll either open up the files of our data in Excel or Google Sheets, and you can calculate the various forces, and then finally you'll graph those forces. So once you've graphed those forces in Excel, you can compare your graph to the graph you drew in question, I think it was number 8, yes. Question 8, see if they seem to make sense. Again, you didn't need to use numbers in question 8, so this gives us more data and actual values, which is nice. And then in question 10, we use this length, again, just a reminder, this is 4 centimeters, not 4 inches, to calculate what the magnetic field in the permanent magnet is going to be, given what we've learned about the length, the force, the current. So with all that, you'll be able to produce the magnetic field. And finally, so just to give you guys a little treat, you guys can go ahead and skip question 12. We're not gonna reverse the current here. You know, if maybe we could play with it if you guys were here in the lab, but if you're not, you're at home being safe, so that's wonderful. Go ahead, skip question 12. I think everyone's going to be able to guess what would happen anyways, but we're not going to be grading on that one for this lab. Now, finally, worth mentioning is the results and conclusions page. Now, your grader, your TA, has basically explained to you what they expect in your results and conclusions page. I find it to be the #1 most important page of the whole lab manual, lab report that you present to me. In short, I find it as basically an abstract of the experiment, an explanation of what you did in that experiment today. It's a great way to explain to, say, a classmate that didn't participate in the experiment what happened during the experiment. And if you have questions, I'm sure that you probably will, given that you didn't have a chance to work with the equipment yourself. If you have questions, feel free to either email your TA or attend one of the Zoom digital conferences to ask your questions, because I think the concepts from the lecture, that whole results and conclusions page really is the most important part. And if you have questions, again, feel free to ask your lab instructor, because one-on-one interaction is really the best way to learn when it comes to these labs. Again, thank you. Nice to teach this lab again this semester. And I wish all of you good luck and to stay safe. Thank you so much. Take care.